Hi students, welcome to Year 9 Science and Unit 2, Our Amazing Earth. This is video number 5 and we're going to be looking at seafloor spreading. And what we need to do in this video is to describe Hess's theory of seafloor spreading. This was an interesting one when I was preparing because seafloor spreading can often come in between the ideas of Wegener's continental drift and also the development of the theory of plate tectonics. But this is an interesting one because I think in some ways Harry Hess's idea, his observation of mountain ranges on the floor of the Pacific led him to propose this idea in about 1962 that the sea floor was actually spreading or growing and moving apart from these ridges in the very center. And at the center of these seas was molten material that was actually being introduced into the crust from the mantle. So his idea was that molten material or magma from the mantle was flowing up and it was actually coming out at the sea floor, and it was then spreading in both directions, and as it did so it created more and more oceanic crust. So that's his idea. Now the interesting thing is, does plate tectonics actually explain Hess's idea, or does the seafloor spreading model actually provide additional evidence in support of plate tectonic theory? It's an interesting one. Either way, there's certainly a high degree of correlation between the idea of tectonic plates, of lithospheric plates, large slabs of rock that are moving around, and at certain places where two of these are moving apart from one another, that material coming up from the mantle may reach the surface and start to cool and solidify and form new crust. So new oceanic crust in this case, as it forms, and what it does as a result of that is it pushes those continents further and further apart from the central ridge as new materials continually being added over and over again. Now, the problem with that is if that was the only thing that was happening, then you would actually expect the whole Earth to be growing. You would expect in some ways that material would be running out from the mantle, that we would actually be kind of shrinking in the center and growing bigger around the edges. That, apart from the fact that it kind of defies a few of the important scientific laws, it also just doesn't make a lot of sense. His idea, of course, is it wasn't just that new crust was being created at these ridges, at these mid-ocean ridges, but also that some of the older oceanic crust was actually being destroyed. Places which we've now known as subduction zones, deep trenches within the ocean, where material comes up, it adds to the seafloor and grows. At the edges, the seafloor can actually start to plunge down below the, say, continental crust, for example, create these great trenches, and as a result of that, some of that older material is moving back in towards the mantle where it's much hotter, and eventually it will liquefy and become part of the mantle. So you actually aren't creating more of something or destroying something. What you're doing is cycling it. It's just continually cycling, and that is the explanation for that whole idea of new ocean crust forming at the ridges and older crust disappearing back into the Earth's interior at these deep trenches, at these subduction zones. I'll just write that down, subduction, because it's a word we're going to look at a little bit later in this video series. Importantly, two critical areas of support for Hess's idea were, first of all, the age distribution. So when we started to look at the ages of rocks either side of a mid-ocean ridge, what we found was a certain symmetry. The further away we got from the ridge, the older the rocks were getting, and we were finding that there was sort of some consistency in terms of how far away we were and how old the rocks were. Of probably even more interest is the fact that the Earth's pole has shifted. So the Earth's magnetic field has shifted over time, which means the North and the South Pole have swapped positions over time. How do we know that? Because there's certainly certain types of magnetic minerals, so certain types of minerals in rocks that are magnetic, or at least that will respond to the Earth's magnetic field. So it allows them to line up kind of like a compass needle. Now we notice that when we start to look at magnetic striping patterns, we find patterns where the rocks are aligned the way a compass needle would be today, which is north towards the North Pole. But in the past, they seem to be flipped 180 degrees. So effectively, the north would be what's currently the South Pole. And that's the alignment that we see. And so there's these sort of consistent and, again, symmetrical patterns around the mid-ocean ridges that kind of tell us that some interesting things have happened to these rocks as they were cooling after being deposited at one of these mid-ocean ridges. So that was certainly an idea worth looking at in a little bit more detail. Those two very important areas of evidence, magnetic striping patterns and also the age of the oceanic floor, were two things that provided some symmetry either side of a ridge. So if the magma is coming up from deeper within the interior of the Earth and it's being deposited, then we've got a certain material that's very young, that's very new, if you like, new ocean crust that's just being deposited right at that point in time. But as we move away from the ridge, what we find is that the rocks get older and they start to exhibit these reverse magnetic field patterns, and those reversals are symmetrical. So we can sort of map them. So as some material comes up, it cools, it aligns in one way. More material comes up, it aligns in an opposite way. So the previous material is aligned one way, and then the new material another way. And then more comes up, and it's back to the original pattern again. So we see symmetrically about our ridge these patterns of magnetic reversals, as well as when we age the rocks, when we try and work out how old these rocks are, we again find these consistent symmetrical patterns, being youngest closest to the ridge and oldest furthest away. Now, one other thing that does lend a little bit more support for Hess's idea is this idea of sediment thickness. The sediment thickness is also increasing as we get further away from the ridge. And that kind of suggests that there's been a bit more time for greater deposition, more substances settling onto that ocean crust, and so therefore slightly thicker as we get further and further away from that mid-ocean ridge, from that brand new crust which is developing, which is just another area of evidence that supports this idea of Hess's sea floor spreading model. So we've got a couple of ideas now that we can look at. We can look at continental drift, we can look at sea floor spreading, and we can look at the theory of plate tectonics, which draws everything together. What we want to do is see if we can use this whole idea of plate tectonics to see if we can apply it to some of the other things that we see happening around the world. But we'll save that for the next video. Thanks for watching.